So yeah,
I'll go first.
yeah.
So I'm Mohit. I'm a director at Meta for the technical programs for Facebook app. In my role, I oversee the teams that are working on different technical platforms. That includes all the recommendations that power videos and feed on Facebook, search, all the creator content, and relevance for stories that you see. Um, yeah, I'm happy to take any questions.
Yeah.
Okay, my turn.
Now, yes.
Hi, my name is Medha Bhutani, and I'm a product development engineering manager at Intel in the data center um segment. And I have, I would say, give or take 20 years industry experience for product development, starting from pre-silicon to production manufacturing phase for all the Xeon series of Intel data center CPUs.
Oh, so for the project, two of our core requirements for the project is that we've picked is one, it should be a GPU hardware accelerated in some way or the other, either for computing purposes or you would use that to effectively train your AI models. And coming to AI models, we need to use some form of advanced reinforcement learning because that is something that a lot of the focus is being shifted to when it comes to self-driving cars, when it comes to research, and again, a lot of it goes hand in hand with how good your computing power and your hardware acceleration is. So you can go one by one on talking about both topics.
Yeah, so I'll go first. I think I'll take an example of how we are seeing the evolution of usage of AI accelerators more so than the CPUs in our applications. I'll take the example of search. So, search in itself is a very niche tech, right? It has its own subcomponents, and most of it has been powered by ML so far. But recently, we have seen this massive shift towards GPU-based AI, reinforcement learning. One example I'll take within search stack, there is something called as query understanding, or it's
Yeah,
called QU. And query understanding basically gives you idea of like what kind of content are you looking for? Are you looking for people? Are you looking for photos? Are you looking for videos? And that you get through getting the semantic understanding of a query that you enter. So far, it was done through NLP, which is natural
mm,
language processing, and that we had like several substacks of ML that were working in NLP to good job. But with the advent of AI, especially LLMs, we are using human language kind of understanding that LLMs provide us to understand queries better, so that we can interpret query like a human does through LLMs. And that has shifted the entire demand side for compute from CPU to being GPUs. And that has fundamentally changed like what we are looking for from the new compute hardware side. And so that to me is a big change. And just one example of like how GPUs are replacing CPUs in all different uh, ML workflows that we had, where things that were done through ML data sets can be now very easily done through LLMs and AI. As far as efficiency is concerned, I think a lot of work that we are doing is more on inference side because the core models are being built once and then used like multiple times for different use cases. And one thing that we are doing recently is moving more and more towards AMD for inference because those are more efficient when it comes to inference. They're also cheaper compared to NVIDIA. servers. So we are, programming our workflows in a way where we can segregate between training and inference and going more AMD for inference so that the overall cost is cheaper. So
Okay.
that hopefully answers the second part of the question that you were looking for, which is around how we are thinking about dividing our workload so that the overall usage is more efficient end to end.
And when you look into people that you hire for uh, developing a part of such teams, uh, what kind of languages, what kind of tools they should be good at? Like, what are certain, because for NVIDIA, CUDA is very important. If you're using GPU hardware acceleration, you should be comfortable with making libraries or at least altering libraries that are written in CUDA. Similarly, for AMD, there is a language. I know there is SYCL for Intel GPU processors. So, uh, how much, what coding languages, what research projects for the hirees you look for, what kind of expertise you're looking for, what kind of experience you're looking for in that sense?
I mean, I can say, at least from Meta side, everybody wants to have people who are like really expert on the frontier model side, but those people are very few. So at the crux of it, we're still
What do you mean by frontier model? Just to
people who are working on actual the models, like the
Okay,
Claude
okay.
and like the GPTs and the llamas of the world. There are very few people who have actually like
Mhm.
on those models. Everybody tries to hire those people, but it's very hard to. And we have hired some of those people, but then we have paid exorbitant amount of money for those. Like you might have heard, like recently Meta like hired 10 or
Mhm.
12 of those folks from like OpenAI and Apple and other places. But for the broader hiring in this space, we're still looking for folks who are good in ML. Because at the end of the day, right, like the core tech is not so different. AI is like a newer version of ML is how you would want to call it, right? So
Okay,
people who are good in mathematics, people who have worked on ML modeling and feature development and data training and all of that good stuff are the same number, same skill set that we're looking for even in AI related roles. So
okay.
yeah.
I would add here, like, of course, Intel is nowhere close to the AI market yet, right? Like, we
Mhm.
are not even catching that train. From a hardware perspective, I would say Intel has a lot of their inbuilt libraries. And the only thing which at least a hardware product development engineer needs for day to day, let's say customizing those libraries for a product that you are working on is C sharp. C sharp is a
Okay,
very,
yeah.
yeah, I think these more than Python, we have moved to C sharp. But the other, skill set is more the tester that we use, the automatic test equipment. And we have an inbuilt in-house tester, but also the advanced test or, the other testers that come from industry. It has a pretty standard, skill set that electronic communication engineer would know. So it's not
Okay.
something to do differently for AI, given that, of course, I'm not in that field. I'm more towards the CPU side, not GPU. But even then, I know the hardware manufacturing teams across Intel over all segments don't have these very specific, languages that you need to know. It's very much in-house that we already have, or a C sharp where you can easily customize the libraries.
Yeah, will knowing C++ plus plus and C sharp benefit you to get hired in Intel or to, because even your in-house languages might be based on
Yes,
some base
yes.
language, right?
Yes. So I think I've seen that shift in hiring, how we used to screen candidates versus now. Prior focus was very much on, CMOS device physics, transistor knowledge.
Okay.
But slowly I have seen that shift where we kind of put a little more attention to what software skills this candidate has. Not too much, again, given that we are more a hardware product development team, but that knack of coding always gives, a candidate that edge of chances of them getting hired is better.
Okay. Okay. And same question in for you also, Meerabua, on now like from meta perspective, it's very core software related
Yeah,
ideas right now. But because you mentioned that Intel is a lot behind NVIDIA and AMD, which is right now the industry standard for
yeah,
GPU and processors. Like even my laptop is AMD CPU and NVIDIA GPU. So keeping that in mind, what do you think uh, Intel can do better to compete?
yeah,
And secondly, how are they coping up with that? Because if you're not in this race, then it's going to be like you have to shift to a very niche thing,
correct.
something like what IBM did back in the day,
Yeah.
and or you need to be like you need to at least come up with some sort of a product that actually can break through and unique.
Correct. And I think the chances of what you said, the second statement that you have to come with a niche product is relatively low today, right?
Yeah.
Given we are not the experts in industry and we have lost that market segment to our competition. So what I would say the new strategy Intel is adapting to is finding these partnerships with other companies, and it's a public news what Nvidia is doing with Intel now, that they are very much interested in the 8086 architecture, which is, the base of this whole silicon that started early in 70s, right? So they are interested in taking that architecture, base from us, using a certain product that we can customize for them for their data centers. In return to, we can use their, the GPU IP for our PC market, right? So it's a give and take. So we are finding these strategic partnerships. Plus, Intel is not in the race for AI. I would say the training model.
Okay.
What Intel is strategizing is more towards the inference, right? They've
Okay.
already moved towards that shift because they can't catch that train. And I think a lot is at stake with our foundry, right? So, given that we have the advantage of in-house fabrication of silicon,
Mhm.
even the CEO and the government is strategizing other companies to come to Intel, pool in that money that we need today so that we can make better product decisions. Um, but and product decisions more towards the, the segment where we are already, we have the edge, which is PC market. Even on the data centers, which is pure CPU, we want to gain back the market segment share from AMD.
Yeah.
And I think the foundry is going to help us with that. And some sort of course, architecture decisions they are taking, which I can't reveal right now.
Yeah.
Yeah, so they are
Okay.
doing with something with the core, which would help us, streamline our manufacturing, streamline our design, so that we are not changing too much over generations. So it's a lot of leveraging from what we have already done.
Okay. Nice. So I'll now give you what we're trying to do. So our project is inspired by Alpha Zero, which came in 2019. Then Meta, it was Google's deep mind. That's how all of it started. They started with beating the Go game, which is 19 by 19. It's like chess, but it's like a mix of chess and checkers, and there's a very specific category. It's one of the toughest games with highest number of game states available if you go down doing PNC on the game states. So uh, we are doing it for chess because there are constraints on the student budget that you have limited time on GPUs. So we'll be trying to use the same methodology, but Alpha Zero functioned purely on reinforcement learning and only the rules of the chess. They didn't train on previous games by experts. Like you can take Gary Kasparov's games, you can take Magnus Carlsen's games that are publicly available, open source. And now Pragnananda has so many games publicly available from Indian chess scene. So we are trying to develop a method that can uh, use the domain knowledge, pre-existing games, understanding spatial uh, aspect of the board using CNN, and then using those weights to initialize reinforcement learning that will end up giving us good results, hopefully a good chess AI. So, so that's going to be our project through line, and we're going to use advanced reinforcement learning with Monte Carlo tree search to basically search down the states and best possible paths and also explore enough so that we can see different strategies and the model can see different strategies as it keeps on playing more games. So keeping this through line in mind and different kinds of data pre-processing, transfer learning, warm starting, then coming to convolution neural nets, and then coming to neural networks that are reinforcement learning based policy and value networks. So keeping all of these in mind, um, what are some of the um, like you can give examples of what are the past products that uh, the company has applied these concepts to, or they are looking to apply certain concepts to certain ideas, certain like they want to do something using these concepts. Are there any big options? Because Meta actually reverse engineered Alpha Zero to make L Zero, I think back in 2020, and then there has been slew of trained over that. So what do you think is because RL anyways is huge right now, considering self-driving cars being the main focus of it. But what do you think are other products where this kind of training methodology and algorithms can actually help it improve?
I mean, I can give you some examples. Like I talked about search, that is like one example where
Yeah.
you predict like what the right result could be. We have a lot of recommendation products where we're using reinforced learning. So for example, like we have come up with these things called deep dive prompts. So on a news feed, we have started showing you prompts on topics, right? So say if it's a post related to say NBA, and we might have a pill based on player in that story, or we might have a pill based on the team in that story, um, or event coming up related to that story. And then we are running these prompts and we're running reinforced learning on the probability of a user clicking on that prompt or not. And that is coming from your interest graph. So we are basically taking a user's personalized interest graph, and then we are showing the relevant prompts based on the match of like probability of that person liking or clicking on that prompt.
Okay.
So we're
Okay.
creating it's a traditional ML thing, but we are using AI to generate those prompts more easy to, first of all, the language of those prompts using generative AI. And the second is like the probability of the prompts that the user will like based on their interests. So that's another example where we are doing using reinforced learning, but it's there everywhere. Like any place
Yeah. Yeah.
do any kind of prediction, right? You will use reinforced learning, and reinforced learning, you can run it without it, but then it'll be very expensive. But with reinforced learning, you can like narrow down the success criteria, success sort of area, and so I would say any application feature that we are building is being built using reinforced learning to increase the success rate and reduce the cost.
Okay. So you can safely say like this is like right now one of the main things that are being integrated in a lot of products. Has there been any features of products where it has been added on. Like there was a working model before, working algorithm before, but you ended up adding it in that also. Like, and it has shown promising results. Like adding a reinforcement learning to it.
I can't think about something off of my head right now, but I'm pretty sure there were many. Right?
Okay.
Yeah. I can't think about a scenario where it was not there earlier and then we added it because the scale at which we operate, it
Hmm.
is sort of given that we have it from the very beginning because otherwise, either the results will not be good or B, the cost will be very high.
Okay. Got it.
Right? So we'll have to like even in like our checklist, guardrails for quality are very, very high. And I don't think we can hit that without reinforced learning.
Okay. Got it. Fine. That gives me enough um to go ahead. Yeah, that's pretty much it. I can show you actually what I am looking at. There's
Yeah.
the, can you see this? So
Yep.
this has been the project proposal for us. So we're trying to basically see how much reinforcement learning is actually affecting, and these are the core things that we'll be trying to tackle with our algo. And
So basically, you're trying to find out how much lift you're getting with reinforced learning.
yeah, and also not treating reinforcement learning as a black box that a lot of the people, a lot of the engineers, at least not working or not in the industry, think about. So just we are seeing how much does just training endlessly with reinforcement learning um, versus making a hybrid model that can utilize compute and still give you good enough results if you have very dedicated data sources. Like, for example, a game like chess, we have so many simulated games. We have leeches going around everywhere. So we have that sort of a idea. And yeah, I mean, below that is just our weekly timeline that professor needed. So, so the core is still this. So, can you like tell us how good of a project it is, or should we add anything specific to a project like this that you might look from the industry point of view?
I think the only thing I will say, which I am seeing a lot happening internally, is use of AI tools to build project like this. I'm talking about like vibe coding, or I'm talking about like cloud code, or like how much of like AI coding or AI assisted coding are you using as part of this project
Okay.
to, because I think like I'll give you an example, right? For the new hires that we are getting at Meta, how good you are in using AI tools is actually a criteria.
Oh, really?
Yeah. 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 Yeah.
So, like, how much of your code that you're generating through AI, is it 50%? Is it 80%? Is it 100%? Like,
Okay.
those things are becoming, and to get there, to increase the percentage, you need to be good at prompting, you need to be good at like context setting, you need to be good at like a lot of other things.